All right, ladies and gentlemen, so we're going to wrap up chapter 6 today with lesson 6.6, which is solving systems of inequalities. To do this, we're going to still work on that same skill we've been working on this whole unit of solving systems of equations, but we're also now going to talk about inequalities and replacing equations, and we'll get there in a minute here. We're going to talk about systems of inequalities. So our only vocab term for today is this idea of a system of inequalities, and it's very similar to our systems of equations. A system of inequalities is a set of two or more inequalities with the same variables. The solution to the system is the set of ordered pairs that satisfies all inequalities. On a graph, what this looks like is our double shaded region. So with my example here, I see that I have my two inequalities. I have the inequality, well, it's shown with equal signs, but it should have inequality symbols between it. And I see that I've shaded this area blue. So that's the solution set for that first inequality. The second one I've shaded yellow, and so what that means, my solution to this system is that green shaded zone. It would be the part that is double shaded. It's shaded for both sets, or both inequalities. So how do we graph these systems of inequalities? Now this slide here is going to be a review, and if you want to write these steps down, I think it's a useful way when you're talking about coming towards the test coming up here. But if you know how to graph your inequalities already, this does not need to be written in your notebook. So the first thing you're going to do is you're going to graph the first inequality in the system. And to do that, you have 3 steps. The first thing is to pretend that that inequality symbol is an equal sign and graph it using how you know how to graph. I have the step written out using slope-intercept form because I think that's the form you're still most comfortable with. But you can do it using standard form or point slope, which we've talked about before. Standard form might be useful for you today, especially as we move into one of the practice problems on the homework. And one of the practice problems, I show you again how to graph using standard form, using the zeros. But once you have the line drawn, you need to figure out, is it going to be dotted or solid? And you have to look at the symbol in order to determine that. Then you take a test point, and the test point 0, 0 is going to be your best choice for most equations. If your line goes through that test point, if it goes through 0, 0, you can't choose it as a test point. Once you've done that, then you can move on to the second inequality. But you really want to make sure you go through all of the steps, that you have the entire inequality graphed, including shading, before you move on to this next step. Then you do the same thing again, and your solution, as we talked about in the vocab, the solution is the set of ordered pairs that's true for both. It would be that double shaded region. One little side note here, you can have an inequality, a system of inequality with no solutions. If we have any shaded regions that overlap, we have infinitely many solutions because there are infinitely many points that would exist in that shaded region. But the one situation that you can have is if you have parallel lines. So let's say I have this parallel line and the solutions are above it, and I have this parallel line and the solution is the points below it. This system would be said to have no solutions because there is no overlapping shaded region. So just a little side note there. Not something you need to know for sure, not a situation that would happen very often, but it could be that we have no solutions. The options for a system of inequalities would be infinitely many solutions or no solutions. It's not possible to have just one solution or overlapping shaded region. Let's practice with this. If I look at this here, these two equations or two inequalities are already written in slope-intercept form, so I'm going to use that to graph. I'm going to pretend that it's an equal sign for my first inequality, and I find a y-intercept of -3. My slope of 4/3 tells me that I go up 4 and over 3. So 1, 2, 3, 4, 1, 2, 3. And I'm going to do it again. Oh, let's make that dot a little bigger. I'm going to do it again going the other direction. I'm going to go down 4 and backwards 3. That's the same slope if I have a -4 over a -3. 1, 2, 3, 4, 1, 2, 3. Now, when I look at my symbol here, it has that or equals to piece, so I know that I'm going to connect my dots with a straight, solid line. Mostly. On your sheet, you should be using, on your notebook, you can sketch. When you're doing this on a homework worksheet or an assessment item, like a quiz or a test, you should be using a straight edge, a ruler, or something else to make nice straight lines. Well, now I need to do the idea of a test point. Test point, in this case, 0, 0 works great. It's not on my line itself. And if I plug in 0, 0, if I plug in 0 for y, well, when I plug in 0 for x, it goes away. I need to determine, is 0 greater than -3? Well, in that case, it's true, so I'm going to shade the side that contains my test point. Now I'm going to do the same process. Let's go with red this time. I see, again, I'm in slope-intercept form, so my first point is going to be at a y-intercept of positive 4, and a slope of negative 2 tells me down 2 and to the right 1. And I'm going to do the same thing the other direction, up 2 and backwards 1. This time I'm going to have a dotted line to connect my dots because I don't see that or equals 2 piece. And again, I can use a test point of 0, 0. When I plug in a test point of 0, 0, I want to know, is 0 less than 4? Which in this case is true again. So I'm going to shade the side that has the test point. Now if I look at this here, I see my 3 shaded zones. I see this first zone here that's false for both. This zone here is true for my first equation and false for the second. This zone here is true for the second and false for the first. But this zone here, and I'm going to shade over it in purple, this zone right here is true for both. And so on a test or quiz item, it might ask you to name a point or a few points that are in the solution set. So I could name 0, 0 is a point in the solution set. I used it as my test point. I could name the point -5, +5. That's true for both. I could name the point -10, -10. That's in the zone. That's true for both. So that double shaded region is my solution set. Well, now let's try again. For the first inequality in this system, I see y is less than or equal to -3. And I know that if I have y equals a number, I have a flat line, a 0 slope. So this time, it's going to be through -3. So no matter what x is, y is always -3. And my line will be solid because I see that or equals 2 piece in my inequality symbol. My test point of 0, 0, well, if I plug in 0, 0, I want to know, is 0 less than or equal to -3? Well, in this case, that's a false statement. 0 is greater than -3, so I need to shade the side that does not contain my test point. For this other one, instead of going through the process and turning it into slope-intercept form, I want to graph it using the zeros, graphing it in standard form. And this is a useful skill that you'll want to use on one of the homework problems tonight. To graph using zeros, what I want to do is I need to find 2 points to define my line. So I want to find when x is 0, what is y? And I want to find when y is 0, what is x? And I'm going to use those 2 points to graph my line. So for the first one, if I plug in x is 0, I have -4 times 0 minus 2y is less than 4. I'm going to pretend it's an equal sign for my graphing purposes. When I do that, well, that piece goes away, and I get -2y equals 4, so y equals -2. So for my first half, I have an ordered pair of 0, -2. Now for the second half, I'm going to do the same thing, but I'm going to plug in 0 for y. So I get -4x minus 2 times 0 equals 4. Well, that winds up with -4x equals 4. So x equals -1. So on this one here, erase that little line, I have -1 and 0. So my 2 ordered pairs, I'm going to go to the point 0, -2. I'll do it with the clicker instead. This one here, oh, let's go with red. It's a little easier to see. 0, -2, and -1, 0. My 2 points define a line, so that's all I need to be able to draw this line here. So let's do a dotted line, because I know, it's a badly straight line. With my dotted line here, I have that symbol that does not have the or equals 2 piece. But again, I can use 0, 0 as a test point because my line does not go through the origin. When I plug in 0, 0, well, I have 0 times -4 minus 2 times 0. So I simplify it down to 0 is less than 4. And in this case, that's true. So I'm going to shade the side that contains the test point. So like before, my solution set is that double shaded region. So if I were going to name some points in the double shaded region, I could name the point, let's see, let's go with +4, -4. This point right here is part of the solution set. So I could write 4, -4. Or any other points. Let's do this one here. I could name 7, -6. I could name points that are in that double shaded region. this part right here. All right, let's try another one here. This one is a little bit different. This is a multiple choice equation. One thing that I need to fix here is my typing doesn't have the negative. The second one should say -4 because that's what matches my lines on the graph. Well, if I do this here, there's a couple different ways I can approach this problem. One way would be to graph it first and then see which graph matches our answer. The other way to do it would be to figure out which answer matches the equation. And so this time here, instead of starting by doing all the work and then just figuring out which solution matches, we're going to use a test-taking strategy and we're going to check the answers that are here. So what I see in this first one is that the origin should be true for both. It's in that double shaded region. In this one, the origin should be true for the first equation and false for the second one. In this one here, the origin should be false for both. And in this one here, the origin should be true for the second equation and false for the first equation. So let's figure out which situation matches the best. If I plug in 0, 0, if I plug in the origin to the first equation, I have 0. Let's make the colors match. The first equation is shaded with blue, so I'll do blue. I should have 0 is greater than or equal to 4. Well, this one is false. So I know that the blue shaded region should not, include the origin. So right now I can knock out A and B because A and B show that the origin is part of the solution set for that blue shading. I look at this here, and that doesn't match. Well, for the second one, let's go with yellow. I should have 0 is greater than -4. Well, that one should be true. So the origin should be in the yellow shaded. So if I have this one, well, that's true for the yellow, but I already eliminated it. This one is false for the yellow, but I already eliminated it. The origin is false. That's not the case. So that must mean D. D shows me that it's false for the first equation. So the blue shaded region does not include the origin, and true for the second shaded region. So the yellow is true. If that was a totally confusing explanation, you can go and do it the other way. You can graph your two lines, figure out the shading, but either way, you should find that it matches the picture for D. This one here is just a test-taking sort of question. You don't need to write it in your notebook, but I thought it was an interesting one to explore with you. This last one should go in your notebook. You can sketch it here. We're taking that idea of applying our systems. We're going to apply the system of inequalities. We're going to define the variables, write the system, graph it, and name a possible solution. So a college organization requires that its members maintain at least a 3.0 grade point average and volunteer at least 10 hours a week. So what I'm going to do is I'm just going to define it. I'm going to say my GPA is going to be X, just to make life easy. So GPA tells me about X and volunteering. Let's try this way. My pens are just not cooperating today. Let's say volunteer, there we go. That's enough. Volunteering is on my y-axis. Well, I know that they're not going to be negative. I can't have a negative grade point average. I can't volunteer a negative number of hours per week. So I only need to worry about my first quadrant here. Label our axes again. GPA is on the X. Volunteering is on the Y. But now I need to write inequalities. So my GPA needs to be at least a 3.0. So X and 3.0. Well, that tells me that 3.0, it could be exactly 3.0. If you have a 3.0, you're going to meet this requirement. But we want it to be a 3.0 or greater. So if I'm looking at this here, 1, 2, 3, 4, 5. I know that it's going to look like 3 with a solid line through it. A GPA of greater than 3 is going to be everything shaded that's greater than 3. For my volunteering, well, the Y needs to be at least 10. So it could be exactly 10 hours of volunteering, or it could be more. We'll skip by 2s. 6, 8, 10, 12, 14, 16. That's fine. Skip by 2s. 6. There's my 10. And I'm going to draw a line across. Again, it's a solid line because I have that or equals to piece, and I know that it needs to be greater than 10 hours. So one possible solution would be, if I have a 4.0, I could volunteer 12 hours a week. So that would be a possible solution, 4 and 12. Really, it should be 4.0 because we talk about grade point averages, we usually use the tenths or even the hundredths. GPA of 4.0, 12 hours. That would be one possible solution to this system. Now in this system, we can talk about the idea of limits. When we're talking about a limit on a GPA, well, a GPA has a limit of 0. We can't have negative GPA. And it has a maximum of 5 if you're in a weighted GPA system, 4 if you're in a non-weighted GPA system. For volunteering, well, there's a minimum of 0. We can't have negative hours of volunteering. And our maximum for hours of volunteering would be, well, our maximum would be 168 because that's the number of hours in a week. But realistically, we probably have a maximum less than that. But we would want to put a mathematical cap of 168. So we could talk about limits on this equation. But the only thing it asks you to do is to graph them and name a solution. Your homework has 3 problems that look like this. The ones that I think are most challenging, let's see, where'd the worksheet go? I think number 4 is the one that's the most challenging. 4 and 5 are asking you to write equations that might be in standard form, and so those are a little more challenging. Think back to your skills about how we can graph with standard form. For your homework assignment, the worksheet is on Teams. You need to upload an image. I want to be able to see your graph so I can see your work. The key, I'm not going to post the key because I want to see what you can come up with first. I will post the key before the test so you can take a look at it and look at your answers for it. Otherwise, this was the end of chapter 6, so make sure that you know what you're doing and that you are ready to take an assessment on this next week. Thanks, ladies and gentlemen.